Hello and welcome back to Data Analysis and Visualization. I'm Jovita Presti, and in this video I'm going to talk about MCDM, which is multi-criteria decision making. So let's begin. Life is complicated and we're often forced to make decisions where several different criteria come into play. And it often seems unclear what criterion should have a priority over other criterions. And mathematicians, being mathematicians, have come up with a mathematical approach that you can use for decision support when you have several criteria or alternatives on which to base your decision. And this technique is called MCDM, which is multi-criteria decision making. And it is useful in a multitude of domains. And we are going to see some such domains right now. You can use this analysis methodology in anything, starting from stock portfolio management to even fashion trend evaluation, from disease outbreak control to land development decision making. Anywhere where you require that you have, many criteria and you want to pick one, you want to make your decision based on those, and also you want to prioritize certain criterion over another, then you can use MCDM methods to help you evaluate alternatives. Let's see MCDM in action. So imagine a scenario where you are analyzing spatial data to evaluate potential sites for a land development project. So let's say that you have been given the task of selecting one ideal site to develop a data center for a company called XYZ Power Company. Now, the land developers who represent this XYZ Power Company, they have told you that you must consider the following criteria, which I'm going to show you now, while evaluating potential development sites. Now, what is that? What are those criteria? So, the first one is proximity to major roads. So ease of access is very important, and that's why if there's a highway going somewhere or some major road where it's easy to do transportation, then that's a plus point. So a site that means a place would get a score of 0 or 1 based on whether or not it's within a 2-mile radius of a major road. Let's see the next criteria. The next criteria is proximity to water and electric utilities. Since you want to build a data center, water is required for cooling purposes, and electricity, of course, is required to keep the servers going. So closer the better when it comes to water and other utilities. So a site would get 0 or 1 based on whether or not it is within a 2-mile radius of major utilities. The next is future land use, which is also known as FLU designation. So knowing what the future brings is also important. So a site will get a 1 if it has a favorable FLU designation and a 0 if it's not quite so favorable. So future land use would mean what would happen in future to that land or the land nearby. What is the use of that? So it's important to know that as well. Sometimes if you're working for some company, say a factory that requires a land or a place to start, then you need to make sure that in future there won't be any residential places, facilities nearby, because you don't want the factory, if there are any harmful emissions or something, you don't want people living nearby to be affected. And at the same time, you don't want at a later stage to have to move the factory somewhere else because this area has developed into a residential area. So future land use is another thing that's important. So if you find out that in future this is what's going to happen to the land nearby or that land itself, then if it's favorable for your project, it should get 1. If it's not, then a 0. The next criteria is zoning designation. So future use is important, but you also need favorable zoning designations in the here and now. So if you have a favorable zoning class designation, then that site would get 1. If it's not favorable, then it would get a 0. So those are some of the criteria that can help you in decision making. Now, during evaluation, each potential site is designated with an X and Y position at the site center. This represents the geographical location of the site on a map. If you imagine that you are evaluating, say, 20 different sites in your city, you'd assign scores to all the 20 sites based on the 4 criteria, and then the sum of the scores would generate 1 score for each site. So there are 20 sites, 4 criteria, you just assign 0, 1, and sum it all up for each site, and you get the total score for each of the 20 sites. To develop a data center on a particular site, the site must satisfy each of the 4 criteria, and therefore if the score is not 4, then you can just eliminate that site from the picture. In mathematics, a set, which you might have studied in set theory, is a group of numbers that shares some similar characteristics. And in traditional set theory, membership is binary. So in other words, an individual member of a set is either part of the set or it's not part of the set. It belongs to the set or it does not belong to the set. If the individual is a member, then it is represented with the number 1. If it is not a member, it is represented with the number 0. And MCDM is also characterized by this binary membership. So there's either a criterion satisfied or a criterion not satisfied. There's nothing in between, so it's 0 or 1. But there is a variant of MCDM, which is known as fuzzy MCDM, which is also denoted by FMCDM. And to evaluate the same types of problems as MCDM would do, but the difference is that it refers to the fact that the criteria being used to evaluate the alternatives offer a range of acceptability instead of just binary crisp set criteria associated with traditional MCDM. So you could essentially assign a score between 0 and 1 as well, and not just 0 and 1. So let's see a little bit more about it. Evaluations based on fuzzy criteria lead to a range of potential outcomes, each with its own level of suitability as a solution. And possible solutions comprise of a spectrum of suitability that's plotted on a chart as something called an efficient frontier. So in fuzzy MCDM, you have the choice to assign a value to a site for a particular criterion, a value between 0 and 1 instead of just 0 or 1. And this allows you to actually plot all those values on a chart. And then when you plot them on the chart, you create an efficient frontier. And then you can decide which particular site you want for your project. Fuzzy set membership is expressed as some gradation of membership. Although fuzzy set membership can be represented by 0 and 1, it can also be represented by any number that lies between 0 and 1, like I said earlier. And the closer an individual gets to 1, the closer it is to being a full member of the fuzzy set. So there is a sort of a gradation process in terms of acceptability. So it's not just accepted and not accepted. It could be something in between. It could be 70% accepted, something of that sort. That is what fuzzy MCDM means. In fuzzy MCDM, you'd assign individuals a membership score based on your certainty or uncertainty about the state of that individuals being a member of the set. So you are assigning a score based on your certainty or uncertainty. Sometimes it's not easy to say for sure if something is certain, or even say for sure that something is uncertain. So a score of 0 and 1 does not make sense. You might want to consider how much sure and how much unsure it is, and based on that, assign a score. Encoding and decoding fuzzy set membership allows a decision model to prioritize or rank individual items within that model. So this also allows you to prioritize criteria based on the score given. So we're going to see that in a minute now. The purpose of incorporating the fuzzy element into the MCDM approach is simply to build in a little more flexibility in how the decision model works when evaluating alternatives. If you want to include decision nuances and even some gut feel into your decision model, then you can use FMCDM, which is fuzzy multi-criteria decision making. So that's right. If you want to introduce some intuition, gut feeling inside your decision-making process, then you should use fuzzy MCDM because it allows you to give scores between 0 and 1. To illustrate FMCDM concept, in the following sections, you should consider in the land development example, as discussed in the preceding section where I explained MCDM. So now I'm going to continue with that and continue with the same land development example. And we're going to see FMCDM in action. So in the land development evaluation, we started with 20 sites. And after doing the MCDM evaluation, we were left with, let's say, for example, 11 sites, which means those 11 scored a perfect 4. But now after these 11, you need to decide which is the most suitable for developing a large data center. So once again, it's back to the MCDM drawing board. So what happens now? This time you're going to use FMCDM to make a comparative analysis of the remaining sites based on the same class of criteria used for MCDM evaluation. So we're going to use the same criteria, but assigning the scores will be done differently. So first of all, it was proximity to major roads. Now in FMCDM, a site is now scored a number between 0 and 1, including 0 and 1, based on how close it is to a major road. The closer the site is to a major road, the closer the score gets to perfect 1 for this criteria. The next criteria was proximity to water and electric utilities. For this, again, a site is given a score between 0 and 1, and based on how close it is to major utilities, the score will be closer to 1. So if a site is very close to these utilities, it will have a higher score than a site that is far away from water and electricity. The third criterion, if you remember, was future land use FLU designation. So here you get it if the sites are scored between 0 and 1. They are based on favorability. So once again, favorability is also ranked from most favorable to least favorable. Most favorable would get a score closer to 1, and least favorable would get a score closer to 0. And the last one was zoning designation. So sites are scored between 0 and 1 based on the favorability of their zoning designation, which is once again ranked from most favorable to least favorable, or highest score to lowest score. Now, once you've evaluated all the 11 sites and scored them based on the criteria, you simply need to sum the scores for each of the sites. So you just have to, there are 4 criteria, so you just have to sum up all that and find the total score for each site. And the sites whose scores are closest to 4 will be the most favorable ones, and the sites with lower scores will be less favorable to use as a data center development site. So this now helps us to narrow down our decision. And you could also add weight factors to FMCDM. What are weight factors? So you're likely to have a list of several fuzzy criteria, but these criteria might not all hold the same significance in your evaluation. For example, in the land development or site development scenario, the developers may have told you that it's important to them that the site has to be closer to major utilities than to major roads. So that's the thing. They have told you that it's not, they do care about major utilities as well as major roads, but they care more about major utilities. For them, water and electricity are more important than being close to major roads. So what do you do now? You add weights to your MCDM criteria. Okay, so because you want to make sure that proximity criterion is weighted, the proximity to utilities is having more weight or more priority than proximity to roads in your evaluation. So how do you do that? You can use weighting factors to quantify the relative significance of criteria in your decision model. And the relative importance of utilities proximity and road proximity might look something like the following. I'm showing it to you now. So if you can add a weight in this manner, you're doing 1.0 into fuzzy score for proximity to major utilities. So site score, this is site score for utility proximity criteria. So you're multiplying that by 1. But when it comes to proximity to major roads, you are multiplying it by 0.5. So you see, whatever is the score of whatever score the site got for proximity to major roads, that score will be halved. So it's 1/2. And when you do that, it has less importance than being close to major utilities. So here the weighting factors are represented by the multipliers that you can see at the start of each of the equations shown in these two equations, as you can see. Now we come to when you can use MCDM in your projects. So to use multi-criteria decision making, there are 2 criteria that have to be met. The first one is multi-criteria evaluation. You must have more than one criterion that you need to optimize. If your project or your question or problem has requires only evaluation and optimization of just one criterion, then there is no need to use MCDM. It is useful when you have multiple criteria that you want to optimize and find a solution for. And the second reason for using MCDM is a zero-sum system. So optimizing with respect to one criterion must come at the sacrifice of at least one other criterion. So what this means is that there must be trade-offs between criteria to gain with respect to one means losing with respect to at least one other. What does that actually mean? So there are 4 criteria: proximity to water and other utilities, water and electricity, proximity to road, zoning, as well as future land development. So there are 4 criteria, but out of these, it's possible that because you want to stress or you want to give more importance to being close to water and electric utilities, you might give more priority to that. So in the process, you might be giving less priority to something else. Obviously, if you're prioritizing one thing, then you are definitely giving less priority to another. And that's why when you have MCDM, it is a zero-sum system, and you should use only when you have multiple criteria and you're ready to prioritize some criterion over another criterion, which could help you to make a better decision. But then at the same time, it wouldn't consider all criteria equally. So that's what the MCDM system is all about. And I hope you understood it. And I'll be back with the next video. So I'll see you there. And Thank you for watching.